Okay, besides Logan, Giselle, who else is not here? Eva. Alex is back. Nicole is here. Nicole's here, right? Hi. So quiet in the back. All right, so the find the area of R. This one's kind of interesting. There was two ways to do it. Which way you prefer? In the X direction or Y directions? You prefer X? X is harder. Yep, X is harder. So I'm going to show you why X is harder. X is harder is because you have to split up this to two different integrals.
Why is that harder?
I feel like it's harder. I feel like it's harder. No, it could be. I mean, that's fine. We can. Yeah, I mean, you can do it either one. I mean, I guess it's okay. So, so why is it harder? I don't know. May not be. Yeah, you were right. It's come to think about it, it's not harder. What I need to do is to first find out this intersection. Can you tell me what this intersection is? At 3 decimal places on AP exam? 0.902. What is a Y? 1.29 something, right? 296? 1.26? Is that's right?
Yeah.
Okay, so I want you to experience this, and I want you to try to do two different ways on your calculator, just because there are two different paths to go this. So first path, so I would say method 1. Method 1 is do it in terms of X. And that's how you calculate the area. It's going to be like this. And then you're going to be like this. Okay, so you're going to have to split in two different, because they are two separate intervals, two separate separation. Do you guys see that?
Yeah.
Okay, so the method 1 is going to be integration between 0 to 0.902, and that's just going to be 10 of x. Plus, now I have to find this x-intercept also. Can you tell me what the x-intercept here? 1 point what? 259. And I don't really need the y value. That's 0 anyway. So it'll be 0.902 to 1.259. And this is going to be 2 minus x cubed dx. And that's the one way to approach it. What is the method 2?
In terms of y.
In terms of y, so then we figure out what would the function. Actually, yeah, you're right. Maybe I feel like the other way is easier, but it comes down to look at it. Maybe the method 1 is easier. So I was wrong. So here I can do it in terms of y. So I can solve for y. So here is going to be x equal to 10 inverse of sorry, x equal to 10 inverse y. Does that make sense? And at this case, it's going to be what? X is equal to 2 minus y to the third root, right? So I can do it in one integral. It's right minus left. Third root of 2 minus y. Right? Minus what? The bottom graph, which is 10 inverse of x. 10 inverse of y dy. And between the boundary is going to be 0.1.266. So it really depends on your choice. You can try it, see if it come out correctly. But this way is calculate area this way. It's going up like this. It's top minus bottom.
And those should both give you the same answers.
It should give you the same exact answers. Supposedly. Unless I did my math wrong. So you guys try it. Right? Each person tries separate ways and try to enter in, see if they can come out the same answer.
I did it the y way and got 0.7293.
Yeah.
You did it at x and you did it in y. So yeah, come out same answer. So it doesn't matter for me. You can come up with whatever way you want. I prefer one way, but actually the way I prefer is actually harder because you had to use the y bound as opposed to the x bound, and you had to convert both equation to the other way. So it's actually harder. That's why I told Connor. I'm sorry, Connor. Apologize. But you also understand more too.
That is facts.
But B, you don't have to split, right?
B, you don't have to split because of top minus bottom. So in this case, just top minus bottom. So it's going to be top, right? Top minus bottom. So it's going to be integration. From the top, it's going to be what? Tangent of x minus 2 minus 3, x to the cube. Oh, it's 2 the other way. Sorry. It's 2 minus x cubed minus 10 of x. And that's between 0 to 0.902. So you got to be able to use calculator to find out intersection. That's what you need to be able to do. And whatever value is, I don't know. The last one is going to be very, very similar to rotation toward x-axis is s. So it's going to be exact same thing, except don't forget the pi, 0.902, 2 minus x cubed to the square minus 10x squared dx. And you don't have to worry about anything else because this is just disk. It's top square minus bottom square. But make sure you have pi. If you don't have pi, it cannot give you credits.
Is there a situation where you square them like at the same time? I feel like there's something you do that for.
You square it at the same time if they're at disk.
Okay.
So one thing that you will probably, let's just say if you will have this area right here, right? Just this is the bounded area, and rotating by x, rotating by y, then you're gonna convert this to in terms of y, and rotate in terms of disk. So in this case, it's gonna be cube root of 2 minus y parentheses square, and pi outside. Does that make sense? Because that's a disk.
Got it.
Got it? Okay. Subtract what, Jonathan?
I subtracted tan x squared.
No, he was showing me an example. Don't worry.
Oh, okay. I thought you were talking about.
No, he was showing me an example. It wasn't a problem.
Now again, this one is a little bit interesting. You had to find out where the x-intercept here, I believe, in order to find r. And to find s here, it's actually, you had to think about a creative way to come up with it, or you want to probably do it in 2 sections, one way or another. S is kind of probably the hardest one. Can you do right minus left? You cannot, because you cannot solve for x. So you had to split the 2. Does that make sense?
See, I was trying to do it in terms of y, but then I couldn't like find the.
Yeah, you can solve for x.
Yeah.
So you can solve for x, so it's not, it's a stuck. So I always think about, what is my process going through. I think about what happened. So find the equation I've written slope form. So basically, Connor was asking that yesterday. So it's f of 3. You just have to figure out the y value. So it's y minus y1 equal to m times x minus x1. And f of 3 is equal to what? I don't know. 9. And f prime of 3?
Negative 3.
-3. So it's going to be y minus 9 equal to -3 times x minus 3. Does that make sense? And then just solve for it because they want slope intercept form. Plus 9. And you probably use this later if I recall.
I think it's probably 18. Yeah.
But you have to use this later, right? Yeah, because you have to find the equation in order. So this question is very well set up. Like you had to use this part. You had to get part A. Otherwise, you're going to screw up with part C. But not part B. You will get credit for part B, but you're not going to get credit for part C if you got C wrong. And yesterday, I think we're talking about, due to that part, you do need to find the x-intercept because you need to know when to stop. So I think the intercept is at 6. Does that make sense? Yes? No? Maybe?
Go over C.
See, the r doesn't need to go over because that's just 4x squared minus xq and
0 to 4.
0 to 4, right? So 0 to 4 and 4x squared minus xq dx, and that's it. That's B. For C is a little bit hard because you had to cut it to 2 sections. So you have to know when to cut and how to cut, because this, if you just do integration here, that is not gonna work because you're gonna find this unnecessary area, which is that's bad. So you had to cut it to 2 parts.
So we have to keep this in terms of x.
You have to keep it in terms of x. You cannot do it in terms of y because there's no way for you to solve for y for f of x.
Okay.
Because you cannot separate the y. It's just not possible. So what you're gonna do is you're gonna split them to 2 individual one, and that's gonna be I think from 6 to 4. That's the first one, and that's easy one. So it'll be negative 3x plus
Would it be 3 to 4?
18. It's 3. Okay, yes, 3.
At least 3 to 4 for that first section.
No, actually, hold on a second. 3. No, it's actually 4 to 6. I was right. Okay, so
Wait, the right side or the left side?
Right side.
Oh, you're doing the
for
right
this
side
part.
first, okay.
and for here it's a 3 to 4, and it's gonna be minus 3x plus 18 is the top, and the minus the bottom, so it'd be 4x squared minus xq dx plus. Because you want to do top minus bottom in this case to get this region right here. And that's the way you had to think about it, because you had to carve out the r between 3 to 4, and the intersection is at 3 to 4. So that's the way you had to think about it. It's a very, very cool question. I really think about the older question is much better. The newer question is actually bad. But I just want to make sure you guys all prepare in case they decided to go back in time. Does that make sense?
Yes.
Okay, so those are a little bit harder one that I think things. R is revolving x, basically just the square and the pi, I think. Right? Find the volume solid about R. Yeah, so it's 0 to 2. This is a part of the disk. So that's the whole thing square to answer Connor's question. So this is part D.
For the test, if you give us the FRQ, do you want us to evaluate or do it just?
So the thing about the older exam, they ask you to solve by hand. The newer exam, on the volume question, they usually just ask you to set up.
And you get more points for setting it up. You only get like 1 point for evaluation.
Exactly. So evaluation is probably the point that you can say, I don't want to do it. I got better thing to do. So if more likely it's gonna be a calculator section. A calculator section, they will just say, hey, just using calculator. So basically, the way to use calculator is you're gonna set this as a y1 and this is a y2, and or like this. And all you gotta do is a y2 square. But make sure you have to have a pi in the front for part D. But I won't type in the equation since I'm gonna graph it anyway. So I will just graph it there and I use that square. I don't have to retype the equation because as long as I make sure the equation is right. So I just do integration of, if you use an inspire, then it's going to be f1 parentheses x and then parentheses square for disk. But don't forget about the pi. Are we okay here?
Mm-hmm. Can you show a couple of the setup problems on the next page?
Yeah, let's do it.
Because I get confused when we switch back between X and Y.
That's fine. Area and volume.
Mr. Ye,
What's up?
is it just like a rule that like math teachers have to like have a specific type of soda that they like to drink in class?
For real.
Why?
It's a thing for
It's
every
a thing for math
teacher.
teachers, like they like just have like my old, like Cooper has Dr. Pepper, like that's
Kogan
his
had
thing,
Dr.
only drinks
Pepper
it.
constantly.
I don't know. That now it comes to think about it, it does.
Like, a lot of
Because
math
I
teachers-
know my algebra T2 teacher has Coca-Cola, and she has a can that can fill up the whole room.
Yeah.
That's how much Coca-Cola she drinks. She died, of course. She died early from diabetes.
Damn.
She did die early from diabetes. I think she died at the 50s. And when I heard she's like 40 something. So, but I remember she collect all the cans. No, I like all different kind though. I don't have specific kind. I have Fanta. I like grape Fanta. I like blue beer. I like orange Fanta. And cherry Coke.
Didn't you ring used to be something else?
Yeah. It used to be like heavy, like metal, like
Yeah.
something scary.
Okay, we're gonna talk about one equation. It's super easy, and this one is complete in Calc 2 now.
Yay.
Yeah, finally, right? Oh, sorry. We're gonna go over some setup.
Okay, thank you. Yeah.
Which one you want to set up?
Just like A, B, just just do a couple of them. I just want to see the differences. I get confused on the differences. I want to see what they are to make sure I.
Okay, I'll try. I'm just gonna.
You don't have to explain them. Just write them out so I can see them.
Okay, so let me see that. Okay, so this one's x minus 2, so it's gonna be here, all the way to 11, so it's gonna be 3, and it's gonna be like this, right? And it's rotate around x-axis. No, this is a boundary, so this is a boundary. So it's rotate around x-axis. This I'm just gonna say this is a y1. So it'll be integration to y1 between 2 to 11 pi squared dx.
What's y1? Square root of x minus 2?
Yeah.
Okay.
So that's a disk, right? Now to y-axis. Now this one is no longer a disk. It's a washer, and so in this case you have to convert everything to in term of y. You want to solve for x. So it'd be y squared plus 2 is equal to x. Does that make sense? I just want to make sure I solve right. Yeah, that's right. So here is top minus bottom. In this case, it's top. Now the boundary is also, the boundary I can write down between 0 to 3. So 0 to 3 always pi. And the way you set up is going to be top minus bottom. So it's going to be 11 minus 11 squared minus the function. So it'll be y squared plus 2 squared dy. Am I missing anything? No, it's good. Now, now what people is going to confuse is they rotate at 11.
Yeah.
Usually they don't have this question. It's called off-axis rotation. They usually only represent one part of the things anyway, so it's not really a big thing. But if it does show up, it's 3 points. So in this case, it's still, I just draw axis rotation, and I draw one line here. So the problem with that line is now represented by y squared plus 2. It's represented by what?
11 plus y squared plus 2?
No.
11 minus y squared plus 2.
This is a functions, right? The red line is a functions, right? So it'll be 11 minus the blue. So it'll be 11. So we're gonna color code this maybe. We're gonna say this one is the black, which is the 11. So 11 minus blue is the 11 minus red. Sorry, 11 minus red is equal to blue. So 11, right, minus the red. Red is the functions. So it'd be y squared plus 2. But you gotta make sure you put a parenthesis because that's sign distribute. If you don't have that parenthesis, it's wrong. So that's the things that you have to think about. Because the function is start from the axis. Am I confusing you? Is it good?
Okay.
So sometimes you had to think about that. And most of the time you had to think in that term that way for the rest of them. Because
And-
all rest of them is called off-axis rotation.
For
So
like-
you had to figure out what happened.
For like F and H, where x equals 13, x equals -3, would you just swap out the 11 for whatever value it's telling you to rotate around?
Well, if it's 13, let's just say if it's 13 is right here, right?
Yeah.
And so you are gonna have the inner and there is outer, right?
Oh, shit, yeah.
So it's actually a washer.
So how would you do that one?
For 13,
I just want to see this.
so it's gonna be pi, still because it's still in term of dy, so it's still between 0 to 3. And the outer is gonna be, this one here is same thing, is 13 minus functions. Instead of 11, it'll be 13 minus function, so it'll be 13 minus a function.
Okay.
So y squared plus 2, and then square, right? Minus 1 square.
2 squared.
Oh, it's 2, my bad, I can add.
I was gonna say.
It's 2 square, yeah. I thought it's 1 because of the way I draw it.
So that 13 you don't, oh no, you do square the 13, all of it, okay.
Yeah, you squared the thing.
Yeah, and you had to distribute a negative sign, so you had to have a parenthesis there. If you don't have parentheses, it's wrong. So that's the thing, you have to have a parenthesis here. So those are a couple hard ones, and those are things that you need to understand. You also need to understand all the cross-section one as well.
That's the stuff I showed.
I like to go over D though. It's rotating around x-axis. It's a perpendicular to x-axis, so it's dx. So that's gonna be x plus x minus 2, right? But the problem is the base is 3 times the height.
Yeah, well, I don't think we learned how to do that. Or, we learned semicircle, triangle, and square.
Yeah, so let's go over the equilateral triangle. The equilateral triangle, I think is square root 3 over 4 outside.
Yeah.
And there's a pi over 8 outside for semicircle. Those are the standard ones. And basically just integration of x. Well, this one's different because this one's perpendicular to y-axis. So that's a little bit different. For this one is, so how do I do base is 3 times the height? So can you explain that? Because that's time we talk about this, right? We talk about this.
I did like if base is b, then h is 1/3 b, and this is the equation for h. So
Yeah.
it's 1/3 of b.
So it'll be 1/3 of the base, x minus 2. And it's between, I think, 2 to 11 still. But there is a pi or no pi in this case? No pi if it's a cross section, because every shape is not circular disc. Is everything is a rectangle.
So why did you multiply it twice?
Because
How do
base
you-
times height.
How do you know it's 1/3 and not 3?
It says in the question. Read it.
Base is 3 times the height. And base here.
You already have the base, right? It's square root x minus 2. But that's 3 times the height. So base is wider than height. It's like actually a word, like word twist. It's a word twist that you guys might have issue with. But yeah, this we already went over something, so you should.
Be squared.
Yeah.
Huh?
Does like it need to be squared anywhere?
You can write it as a square. If you square both of them, it's going to be 1/3 x minus 2.
Okay.
Wait, how is the square root of x minus 2? How is that the base?
That's the distance from here to here. That's the distance from here to here. That's the base.
Okay.
Because each base is going to have a different, different rectangles, right? Questions?
So you're just multiplying those together?
Yep,
Okay.
for that particular one. I think Margot has all the answer worked out, right? Yeah, so if you want to check with her, she does. But I check with her, like we go over all of them, I think. Yeah. How much time I have?
Like 20 minutes.
Good. Let's talk about calculus 2. Yeah. Now, like I say, forgive me, you guys are guinea pig because I'm gonna be the first time. I actually learned majority calculus 2 during the Christmas break. So
Yeah. Oh, holy. Do you understand it all?
90% of them. We'll see.
So does that mean we're gonna get like a 10% curve on everything?
You had 10% cover on everything, sure, whatever. I'll just make 10% harder and then it didn't matter.
Well, then what?
Gray is irrelevant. And it's gray is irrelevant. So instead of calculating the area of something, there is just a formula you have to remember for arc length. So I'm gonna write down the arc length. Am I showing on the board? Now, I think you only had to worry about in terms of x aspect because the AP exam they don't really test the y aspect as much. But I'll write it for you just in case you need it. So s equal to square root of 1 minus f prime of x square. That's it, dx. So integration of a and b.
What is this for?
So for arc length. So if I say, I want to find out a parabola, right? We're just going to give you a simple equation. And then we say we want to find out this parabola, like this length, the length of that. We don't want an area.
Of the line itself.
Yeah, of a line of itself, then you just have to do that. That's like, you just have to plug in the equation. So let's just try it. Let's say I don't know if this will work, but we'll try it. So we're gonna give a function that is a little bit difficult. So we're gonna say, sorry, let me just write down here. So this length is called the arc length between 0 to 2. And basically, you just have to follow this equation. So we're going to use one that at least we know that will work out very well, because sometimes you're going to have some equation is not going to work out under the square root. So we're going to give you this equation of x cubed over 6 plus 1 over 2x. What do you have to do first?
Take it
Less
through.
than now.
Take a derivative. Good. Let's take a derivative. Yeah, because we can figure out a bound in a second. Actually, did I give you a bound?
No.
The bound is going to be the arc length is between 1/2 to 2. So we can take a derivative of this. So what's going to be? X squared over what? 2? And what's the derivative of 1 over 2x? So 1 over 2x to the negative 1. So if I take a derivative of this, it's going to be what? Negative 1 to x squared. So this one is going to be negative 1 over 2x squared.
That feels like you can simplify it.
We can factor out 1/2 to make life easier. So it'll be x squared minus 1 over x squared. So all we gotta do is plug in. So the arc length, just plug in. So it's equal to integration from 1/2 to 2, because that's a boundary we want to know. This one's kind of ugly number. So square root of 1. Sorry, this is plus. My bad. This is plus. I wrote it down wrong. This is plus. So it is plus This one's plus, make sure. Sorry, I did write down wrong. It's plus. So 1 plus is going to be 1/2 times x squared minus 1 over x squared squared dx.
Do we need to solve this?
Technically on this will be on the calculus section instead of non-calculus section. So we're gonna try to solve it. So we'll say it's equal to between 1/2 to 2, and then we're gonna square this. So it's gonna be 1 plus. This one is gonna be squared. It's gonna be 1/4. Does that make sense? And then you're gonna square this on the side. So let's square this on the side. I don't know why I pick 1 is so complicated, but anyway. So can you guys square this? So it'll be x to the 4th. X squared times negative 1 over x squared is going to be what? Negative 1 and negative 1. And then what?
1 over
Minus 1 over x squared. No, x4, sorry. So it'll be x to the 4th minus 2 and a plus, sorry, there's a plus 1 over x to the 4th. I'm trying to see if I did anything wrong. Okay, so what happened here? I'm going to distribute this, right? So that's equal to square root 1 plus 1 over 4 x to the 4th. And then this one is going to be what? 1/4 minus 1/2. 1 minus negative 2 is what? Minus 1/2. And plus 1 over 4th x to the 4th. If I subtract that, it's going to give me what? It's going to be 1/2. So it's going to be 1/4 x to the 4th plus 1/2 plus 1 over 4 x to the 3rd, x to the 4th. Can I take out 1/4 out? And then that's going to give me what? X to the 4th plus 2 plus 1 over 2x to the 4th. No, sorry, it's 1 over x to the 4th. And it actually turned out pretty nice. Why is that? Because you can square root this now. This is a 1/4. This one's going to be x squared plus 1 over x squared. Square. Does that make sense? And then that's going to be integration, sorry, that's going to be integration of 1/2 of x squared plus 1 over x squared and dx. So now you can integrate this. So it's just some math that you got to deal with. Now, the AP exam is going to give you a much easier question than a textbook give it to you. But basically, you just need to learn how to apply the formula. Now, I'm not going to work at the integration signs, but you will end up to get 33 over 16. but you guys should know how to take integrate of that. But we already did all the algebra hard part, and just you had to distribute and just kind of work through. In this one, you can actually take out 1/4 and square root it, the whole thing, and it will work out pretty well. So I'm gonna give you one that you can manage. How about that? This one's a lot of algebra. We're gonna give you less algebra, so we're gonna give you trigonometry.
Oh, I was about to.
But it's actually easier.
Okay.
Natural log cosine of x between 0 to pi over 4. And you need to know integration of secant, by the way. You guys know integration of secant? Huh? What's the integration of secant?
You said like you substitute secant tangent.
Almost. It's actually secant of x plus tangent. So it's natural log of secant of x plus tan of x. Write it down if you don't remember.
Say that again.
Integration of secant of x dx is equal to natural log of secant of x, tan of x, 10 plus tan of x plus c. You're gonna know why you need that. So the way they give it to you is not gonna be so much algebra intense. I just pick one example. It was a very bad example.
What did you say the answer for the last one was?
33 over 16.
Oh, over 16, okay. Yeah, using a calculator would have just been a lot easier then.
Yeah. I mean, I won't give you something like this bad. I will just give you something that is relative. It's okay. Now, so I'm not going to test, I'm going to test like a very simple one, just like this, just arc length. Not big deal. I'm going to actually pull the question from the AP exam book. It's going to be something like this, relative easy. But this will be something a little bit different, which is natural log of cosine. You should end up to be integration between 0 to pi over 4 secant of x plus secant of x dx. Nisha says, yeah, I got that.
Like at the very end?
At the end.
Oh, okay.
Mr. You said you're gonna test this tomorrow, like a simple one?
Yep. But this is just remember the equation, right? Square root of 1 plus f prime of x squared. There's no pi outside, just boundaries. What's the derivative of natural log of cosine of x? Negative tangent, right? D to the dx equal to negative tangent of x. But it turns out it doesn't matter because it's going to square anyway. So it'll be 1 plus what? Tangent square of x, right? And you guys should know what 1 plus tangent square of x is. Is secant square of x. And what happens is the square root secant of x is 0 to pi over 4 of secant of x dx. It turns out very, very nice. Okay, and the AP exam question is going to turn out pretty nice. And this one is going to be natural log of secant of x plus tan of x. To review a little bit, this one is a real one. Pi over 4 and 0. You will plug in natural log of secant of pi over 4 plus tangent of pi over 4. It turns out we know both. Minus natural log of secant of 0 plus tan of 0. And we also know both. But the problem is, do you guys remember your thing? What is secant of pi over 4?
2 over
square root 2
Square root
plus tangent of pi by 4,
of 1.
1, minus natural log. What is secant of 0?
Plus.
What is secant of 0?
1.
1. No, secant of 0 is 1, yep. Plus tangent of 0 is 0. What's the natural log of 1? So be natural log of square root 2 plus 1. And that's the final answer. And that's equal to 0.881. And this is an answer that is on non-calculus sections. And this will be the answer in the calculus sections.
Okay.
So it depends on
So
which
if I
one.
was in a calculator section and I just got to the first part where it's 0.
Yeah, you just had to do this. You just have to do this. You don't have to do anything else. Just plug in and you're done.
Alright.
Will you always round to the third decimal?
Always 3 digits, 3 decimals. On AP exam, don't round it to the first one, round it to 3. I don't know if it's same thing in physics. No.
I think, was it sig figs on, because of,
Oh, they go by sig fig? Oh.
I don't
or
remember.
do you just put? I
Sig
think
fig
you
is
just
so
put an
gross.
answer or whatever.
In chemistry, it is 6 figs.
Some questions are sig figs, not all.
Oh. I hate sig fig. I was a chemistry major too. I hate sig fig. I was like, just take my point off. I'm gonna write down 3 decimal places. Sig fig is bad.
It's bad, but like I feel like
Depend on what your data is, right?
But I feel like a lot of people make it seem worse than it is.
Yeah.
I'm sorry, how did you get secant of pi over 4 again?
That means cosine of pi 1 over cosine of pi over 4. So 1 over cosine of pi over 4 is equal to 1 over square root 2 over 2. So it'll be 2 over square root 2. Rationalize it. So it'll be 2 square root 2 over 2. 2 cancel out, square root 2.
Wow.
Do not know what secant
You didn't do your homework, kid. Shut up.
But at least I know what secant pi over 4 is.
Yeah, but you don't know anything else.
I know cosecant pi over 4.
Okay. Good. Do you know what's cotangent of pi over 3?
Cotangent pi over 3 would be 8.
I bet Nicole doesn't know. Nicole, when it comes trick, she just shut her brain out. She's like, what trick?
Am I dead?
Huh?
Is it 1 over square root 3?
Yeah, actually.
Oh my god. See, I'll tell you anymore. I'll come back later.
Good job.
That's
Proud of you.
tangent,
Huh?
though. That's tangent.
No, it's cotangent.
No, tangent would be.
Tangent is 1 over square root 3.
Yeah, no shit, she's right.
Right? Or no?
No, she's right.
She's right. What the hell?
Because cotangent of pi over 3 is same thing as tangent of pi over 6. Tangent of pi over 6 is square root 3 over 3. Okay, so I'm going to give you one more formula, but don't worry, it's not tested. Not tested by me, not tested by AP exam, so, but I'll just give you in case you ever need it, in life to try to figure out a surface area of a base or something. I don't really care if you know how to do it because it's not on the exam. So this one is the surface area of revolutions. So S equal to 2 pi. It's very, very similar, except there's a Rx outside, and this 0 to the B, or A to B, sorry. The boundary is going to be 1 plus F prime of X square dx. So this is the definition of area of surface of revolution. Let's rotate around X. But I'm just going to set up for you. That's it. I'm not going to worry about it. If I have some function like this that says y equal to x cubed and between 0 to 1. So I'm going to say 0 to 1 of 2 pi. Does that make sense? And the function is, this one is the function. So this is going to be Rx. So that is going to give you a x to the q. square root of 1 plus 3x squared dx, and that's it. Just plug in, you just set up, and that's it.
So the thing in front's R, not like B or anything?
The r of x is just the radius, so it's gonna be the functions. So it's gonna be x cubed.
So R of x is just going to be f of s every time.
No, if you rotate on y-axis is different, so we're not gonna talk about that. But if you rotate on x-axis, it's gonna be because they are revolving here, right?
Yeah.
They're revolving here, so this is the r of x,
All right.
which is in this case is the length. Now there is a way to rotate this way. It's gonna be the same function, but you just have to do it differently. So rx is gonna be different. R of x is gonna be x if you rotate around here,
Okay.
because this is distance from here to here. So it really depends on how axis rotation to whatever. So